Imagine a vast desert, the Jurub Desert in Chad, Africa. The year is 2001. A team of scientists is searching. They are looking for clues to our deepest past. They are hunting for the fossils of our ancestors. One day, they find something incredible. It is a skull, ancient and crushed. It looks partly like a human and partly like an ape. They name it Sahelanthropus chadensis. The world comes to know it by a simpler, more personal name, Toumaï. This name means hope of life in the local language. Toumaï lived about 7 million years ago. This discovery was a thunderclap in the world of paleoanthropology. It pushed back the story of our family tree by millions of years. The skull of Toumaï was a puzzle. It had features that surprised everyone. Its face was relatively flat, more like a recent human ancestor than an ancient ape. Yet, its brain was small, similar in size to a chimpanzee's. This mix of old and new traits was fascinating. But the most important question remained unanswered. How did this creature move? Did it walk on two legs like us? The position of a hole at the base of the skull, called the foramen magnum, offered a clue. Its forward placement suggested that Toumaï might have held its head upright. This was a hint, a tantalizing possibility that it was a biped, an early member of the human lineage who walked tall. For years, the world believed the skull was the whole story. Scientific papers and museum exhibits focused entirely on this remarkable cranium. Textbooks were rewritten. Our family tree was redrawn, with Toumaï placed near the very root, close to the moment our path diverged from that of chimpanzees. The skull alone was enough to spark endless debate and wonder. It was presented as a singular treasure, a lone beacon shining from the dawn of our existence. The scientific community celebrated this find, analyzing every ridge and curve of the bone. They built theories and painted pictures of Toumaï's world based on this one spectacular piece of evidence. This focus on the skull made sense. It was the most complete part of the find and offered so much information. But science is a process of discovery, and sometimes the full story takes time to emerge. The tale of Toumaï, as the public knew it, was incomplete. It was like reading the first chapter of a thrilling book and thinking you knew the ending. An essential piece of the puzzle was missing. A secret was being kept, locked away from public view. This hidden chapter would eventually challenge everything we thought we knew about this ancient relative and the scientists who found it. The desert had given up more than just a skull. While the world was captivated by Toumaï's face, a different story was unfolding behind the scenes. The team that found the skull had also found other bones. They were discovered in the same location, at the same time. Among these fragments was a piece of a thigh bone, a femur. This bone was crucial. A femur can tell scientists exactly how an animal moved. It holds the secret to whether a creature walked on two legs or four. Yet, for more than a decade, the existence of this femur was not officially announced. It remained unmentioned in the grand publications that introduced Toumaï to the world. The story of our oldest ancestor was missing its legs. Why the secrecy? In the competitive world of science, this is not as unusual as it sounds. The researchers who make a discovery often feel they have the right to study it first. They want to be the ones to analyze the fossil, write the definitive paper, and claim the credit for what it reveals. This is part of the culture of paleontology. It can take years to carefully clean, study, and understand a fossil. The team, led by French paleontologist Michel Brunet, was following these unwritten rules. They held on to the femur, intending to publish their findings when they were completely ready. They were protecting their discovery from competing researchers, but secrets are hard to keep, especially in science. Rumors began to spread through the scientific community, whispers at conferences, questions in university hallways. Other researchers heard that a femur had been found. One scientist, who had been part of the original team, left and allegedly took photos of the bone with him. He later presented his own analysis, suggesting the bone did not belong to a biped at all. This created a tense situation. On one side, you had the official team staying silent. On the other, you had outsiders, trying to piece together the truth from second-hand information and unofficial reports. The pressure began to build. Journalists started asking questions. The story of a hidden bone was too compelling to ignore. It raised questions about scientific transparency. Should a discovery this important to all of humanity be kept under wraps by a small group of researchers? The silence from the main team only fueled the speculation. Was the femur being hidden because it contradicted the story told by the skull? Did it show that Toumaï was not a biped after all? The mystery of the missing femur became a controversy, casting a shadow over the hope of life. The world wanted to know the truth. The situation couldn't last forever. The dam of secrecy finally broke in 2018, not with a grand announcement, but with a leak. Another researcher, Roberto Macchiarelli, published a study based on his own analysis of the femur, using measurements he had acquired. His conclusion was explosive. He argued that the shape of the femur was not consistent with a creature that walked upright. Instead, he claimed it looked much more like the femur of a primate that moved through trees and walked on all fours, like a chimpanzee. This directly challenged the idea that Toumaï was one of our earliest bipedal ancestors. The controversy was now out in the open for everyone to see. This unofficial publication forced the hand of the original research team. After nearly 2 decades of silence, they had to respond. In 2022, Brunet's team finally published their official detailed analysis of the femur. They also included studies of 2 forearm bones, or ulnae, that were found with it. Their paper told a very different story from the one Macchiarelli had presented. They argued that, yes, the femur showed Toumaï was an excellent tree climber. This was not surprising for a creature living 7 million years ago, but they also pointed to features in the bone that indicated it frequently bore its weight in an upright position. The official paper described a creature with a complex way of moving. The forearm bones, for example, did not show any signs of knuckle walking, the way chimpanzees and gorillas move on the ground. When you put all the evidence together, the skull, the femur, and the forearm bones, a new picture of Toumaï emerged. This was not simply an ape, nor was it a fully committed biped like later human ancestors. Sahelanthropus was something in between. It was likely a creature that could walk on 2 legs when it was on the ground, but was still very comfortable climbing and moving through the trees. This new evidence didn't solve the debate, it deepened it. The scientific community was now split. Some sided with the idea that the femur proved Toumaï was not a hominin, not part of our direct family line. Others saw the evidence pointing to a facultative biped, a creature that walked upright when it needed to. This kind of complex movement might be exactly what we should expect from an ancestor living so close to the split between humans and chimpanzees. The femur, once a secret, was now at the center of one of the biggest debates in human evolution. Its journey from the desert sands to the pages of scientific journals was a lesson in itself. So, what does this all mean for our human story? The discovery of the Sahelanthropus femur and the controversy around it teaches us 2 important things. First, it reshapes our understanding of how we came to walk on 2 legs. The evolution of bipedalism was not a simple, straight line. It wasn't a single event where an ape-like ancestor suddenly stood up and started walking. Instead, it was a messy, gradual process. There were likely many experimental forms, creatures like Toumaï, who could move in multiple ways. They were pioneers, adapting to a changing African landscape. They were at home both in the trees and on the ground. The femur tells us that the journey to becoming human was not a clean break from our ape-like past. For a very long time, our ancestors retained their ability to climb trees. This was a useful skill for finding food and escaping from predators. Walking upright might have started as just one of several ways to get around. The story of Toumaï suggests that the first steps toward humanity were tentative. They were taken by creatures who were still deeply connected to the forest world of their ancestors. The femur is a physical reminder that evolution doesn't make sudden leaps. It takes small, hesitant steps. Second, the saga of the hidden femur teaches us a valuable lesson about science itself. Science is not just about facts. It's a human activity. It's filled with competition, ambition, and sometimes secrecy, but it is also self-correcting. The pressure from other scientists and the public eventually brought the evidence to light. The ensuing debate, with different teams interpreting the same bone in different ways, is not a sign of failure. It is the scientific method in action. It is how we test ideas and slowly move closer to the truth. The controversy pushes everyone to be better, to re-examine their data, and to defend their conclusions. In the end, the story of Toumaï's femur is as important as the bone itself. It reminds us that our understanding of the past is always changing. Every new fossil, every new analysis, adds another piece to the grand puzzle of our origins. Toumaï, our 7-million-year-old relative, is more mysterious and more interesting than ever before. This creature, which could walk upright on the ground and climb through the trees, represents a pivotal moment in our history. It stands at the dawn of the human journey, a testament to the complex and wonderful path that evolution took to create us.